Welcome to Pre-Calculus. Today we will investigate how to create the unit circle. We'll start with a circle that's got a radius of 1. So you can see as we've got our diagram here, this circle passes through the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So it's definitely got a radius of 1. Now, on the unit circle, we really have two main tasks that we want to complete. The first is to mark the angle measures. And we want to do that in two different ways. So we'll start with our traditional degree measurement. So where we begin on the unit circle is standard position. That's the positive x-axis. And where we would start with our numbers at that standard position is with 0 degrees. Now, once I've marked that, I'm going to mark now the increments that are 90 degrees. So you kind of take it by pieces to create the unit circle. So this first positive y-axis is definitely 90 degrees from my positive x-axis. And we'll keep going with multiples of 90. So here at the left side of the unit circle is going to be 180 degrees. And then if I add 90 to 180, that's going to get me down here to 270 degrees at the negative y-axis. And then as I reach back around to where I began at standard position, I would mark that as 360 degrees. So we start to see that different positions on the unit circle can have different angle measures depending on how many times I've wrapped around the circle. We could keep going even with 360. If I went another full rotation, I'd be at 720 degrees. So those are the 90s. Let's add to that the 45. So I'm going back to standard position. 45 degrees is halfway to 90. So I'll mark it there near the origin. And then I'm going to mark 45 degrees here out at this ray. So if I add another 45, we're back to 90. 90 plus 45 will get me to 135 degrees. 135 plus 45 is 180. 180 plus 45 is going to give us 225 degrees. 225 plus 45 is 270. And then 270 plus 45 is going to give us 315 degrees. And then I'm back at 360. The other marks that we want to note here on the unit circle are our 30-degree measurements. So I'm going to come back to these two rays that we hadn't marked in the first quadrant. The first is going to be indicative of 30 degrees. And then the second, if I add another 30 degrees, is 60. So we'll continue that pattern as well. 60 plus 30 is back to 90. 90 plus 30 is 120 degrees. 120 plus 30 is 150 degrees. And then we're at the halfway mark at 180. 180 plus 30 is 210. 210 plus 30 is 240. 240 plus 30 is 270. 270 plus 30 is 300. And then 300 plus 30 is 330. And you can see if I add 30 to 330 again, we're back at 360. So we currently have all the angles marked in degrees. What we want to follow up with that is markings for these same angles, but now in radians. So we'll start and we'll just kind of note that these are equivalent angle measures. We marked degrees first, but with radians, we got a different view. So I'm going to start with 0 radians. You start at the same standard position. And instead of doing the 90s first, I just want to remember that if I go a full rotation around a circle, really what radians is describing is a ratio of the circumference to the radius. And so because this circle has a radius of 1, I can take the circumference formula, which is circumference equals 2 times pi times the radius. Well, if my radius is 1, our circumference is going to be 2 pi times 1, which is 2 pi. And that's where we get this full rotation. If I were to rotate entirely around the circle, I would get back to 2 pi, and that's equivalent to 0. So that's a good place to begin with the radians, because now I know that the full rotation is 2 pi. So now I can start separating them into parts. So half rotation, which is 180, is going to be half of 2 pi, which is just pi. And then I can mark now the 90s. Half of 180 is 90, so half of pi is equivalent. That's going to be pi over 2. And then 270 is going to be, if I think about that, 3/4 of the full. In fact, I've marked that in the wrong place. Three pi over 4 is going to be here with 135. And let me back up to this first 45. So half of pi over 2 is going to be pi over 4. Okay, so we're in our pattern now. So I've got the first group of 45s marked. So now I'm going to start at pi, and I'm going to add pi over 4. So that's going to give me 5 pi over 4, which is equivalent to 225. And then back here at 270 now, that's going to be 6 pi over 4, which would reduce down to 3 pi over 2. And then 315 would be 7 pi over 4. So just to recap what we've done with radians, we started with 0 and saw by the definition of radians that that's equivalent to 2 pi if I make a full rotation. And then we just cut that into quarters to get our 90s, and then in eighths to get our 45s. So you can think 2 pi divided by 8 is pi over 4, and then we can just add. Now, those are my 45s, so I do need to come back and mark also the 30s. So you can think of 30 degrees, there's really, if I think there's 3 of those in each quadrant, and then there's 4 quadrants, so there's 12 total increments of 30 degrees. So 2 pi, the full rotation, divided by 12 is going to reduce to pi over 6. So I can use that as a way to mark these others. So if I go to 60, that's twice 30, so that's 2 pi over 6 or pi over 3. One more will get me to pi over 2. One more will get me to 2 pi over 3. And then one more 30 would get me to 5 pi over 6. And then I'm halfway at pi. So now I'm going to add 30 degrees or pi over 6 to each of these values to label these lower increments of 30. So now I'm going to have, you can think pi is like 6 pi over 6. So 210 is going to be 7 pi over 6. 240 is 8 pi over 6, which is going to reduce down to 4 pi over 3. 270 would be 9 pi over 6, which we've already got reduced to 3 pi over 2. 300 is 10 pi over 6, which is 5 pi over 3. And then 330 is 11 pi over 6. So that completes it. We're looking now at our unit circle with 2 ways of labeling our angle measures. We've got degrees and we've also got radians. So that's one of the things that we want to complete on the unit circle. Now, we also need to mark the coordinates of the places on the unit circle where our lines are crossing the circle itself. So I'm going to mark them here. I need to find the coordinates of these places on the unit circle where the rays are crossing it. So I'm going to mark them there in red. And the reason I want those coordinates is essentially that's going to give me my output values for sine, cosine, and with a little algebra, tangent. So what I need to have in view as I create these coordinates are my 2 special right triangles. So what I'm going to start with is the 45, 45, 90 triangle. So we've seen these in a different context and kind of a problem solving setting. We need it here on the unit circle. So I'm just going to note, because it's a unit circle, the radius is going to have a value of 1. So recall on the 45, 45, 90, to get to the legs from the hypotenuse, I divide by the square root of 2. So that I would need to rationalize. So I'm going to multiply by the square root of 2 above and below. And what that's going to give me is a value for this lower leg of square root of 2 over positive 2. And then because it's a 45, 45, 90, the vertical component has the same measurement. So let's mark our 45. So the way we're going to see those triangles here on the unit circle is really kind of with a corner there at the origin. The 90 is going to be along the x-axis, and then the other vertex up actually on the circle. So again, if I mark those lengths, square root of 2 over 2, square root of 2 over 2, what that gives me is a coordinate here of exactly that. It's going to be the square root of 2 divided by 2, comma, square root of 2 divided by 2. Now I can use that idea to mark the other coordinates. So I'm going to go to the 90. That one I can mark exactly as 0, comma 1. Over here at 135, if I draw in that 45, 45, 90 triangle, it's got the same dimensions, but notice that because we're here on the negative x-axis, that the x coordinate's going to be negative. So it's going to be negative square root of 2 over 2. Y coordinate's still positive, square root of 2 over 2. So I'm going to clean up our unit circle just so that it doesn't get too full. It kind of has a tendency to do that. And let's continue marking our 45s. In fact, I'm going to include the 90s as well. So here at 180 or pi, that's going to have the coordinate negative 1, comma 0. Here at 225 or 5 pi over 4, that's going to have both negative x component, negative square root of 2 over 2, and the y value is also negative. 270 would have the coordinate of 0, comma negative 1. 315, here the x coordinate's positive. We're on the right side of the y-axis, but the y coordinate's negative. We're below the x-axis. And then last place here for the 90s is going to be 1, comma 0. And that's our standard position. So we've got then our 45s. Now, the other angle measurements are going to be given by the second type of special right triangle, which is the 30, 60, 90. So just to kind of keep that in view again, I'm going to draw it here. And again, because it's unit circle, my radius is 1. So then to get back to the shorter leg, remember you divide the hypotenuse by 2. So that's going to be half. And then from the shorter leg to the longer leg, we multiply by square root of 3. So that's going to be square root of 3 over 2. So just like we did with our 45s, I'm going to mark our 30-degree increments with their coordinates. So here you can kind of see this 30, 60, 90 triangle here in standard position. So it's going to have the coordinate square root of 3 over 2, comma 1/2. And we'll continue with that again around the circle. So let me mark the ones that are with this kind of arrangement where the triangle is in a way lying flat against the x-axis. So I'm over here at 150. That's going to be negative square root of 3 over 2, positive 1/2. Down at 210, that's going to be negative square root of 3 over 2. The x direction is negative, but also the y, negative 1/2. And then over here at 330, that's going to be positive square root of 3 over 2, positive 1/2. And I hope you've paused there. That's not going to be positive 1/2, but negative 1/2. I'm below the x-axis. So almost got all of our coordinates marked. I'm just again cleaning up our diagram so that it doesn't get too full. So what's left for us to mark now are the 60-degree increments. So in truth, what we use for those is the same 30, 60, 90 triangle, but we're going to orient it with the shorter leg on the x-axis, the taller leg vertical. So it's the same triangle, but the dimensions will switch. So one is still our hypotenuse, but now the horizontal is half, the vertical is square root of 3/2. And where we'll start with that is our 60 degrees. So notice it's the same coordinates, just flipped. So as 30 degrees, so it's going to be half comma square root of 3/2. And then we'll continue marking the other increments of 60. So over here, 2 pi over 3, or 120 degrees, is negative half comma square root of 3/2. And then dropping down to now 240 degrees, that's going to be negative half negative square root of 3/2. And then the last coordinate to mark here is at 330. That's positive x direction, negative y direction. So positive half negative square root of 3/2. And that completes our unit circle. So just again to recap about what we've labeled there, we labeled the angle measures both in degrees and in radians. And then we came back and labeled the coordinates using our special right triangles, keeping in mind that it's the unit circle where the radius equals 1. As a final note, just to kind of say, kind of preview how we're going to use this, really the unit circle is here for us to help us graph the trigonometric functions. And essentially what we've got here recorded with these coordinates are values for sine and cosine, and if we do some manipulation, tangent as well. So just to kind of predict where we're headed, our cosine values are going to be given by the x coordinates. And you can think about, like, why is that the case? Well, if I'm on one of these special right triangles, in fact, let me take the pi over 4, then the 45/90. So square root of 2/2. Remember, to calculate cosine, if we're at this angle 45 here, we'll just kind of label it theta. That's going to be adjacent over hypotenuse. Well, adjacent square root of 2/2, hypotenuse is always 1. So in fact, all of the x coordinates are my cosine values. So I'm going to go through and highlight them, because ultimately that's the use of the unit circle, is to use this to help graph, well, from the x coordinates cosine. And as we reach the full rotation, then we can switch and say, well, if the x coordinates are values of cosine, the y coordinates are going to be values of sine. So again, I'll go through and highlight those. We're going to use them when we go to graph the sine function. Now, that's for these just x or just y coordinates. Again, the x is the cosine value, the y is the sine value. And then one final use of the unit circle is I could then take and calculate my tangent values. It takes a little bit of algebraic work here, but you would just take your y coordinate and divide it by your x coordinate, and that would give you tangent. So just to illustrate, if I took my coordinate for 30 degrees, that would be half for the vertical over square root of 3/2 for the horizontal, and that's my tangent value, because that's the opposite side divided by the adjacent. Now it does take a little bit of algebraic manipulation to get that into a place to where I actually can use it as a value, I would have to multiply by 2 to cancel my 2's. That would give me 1 over square root of 3. And then I would need to rationalize the denominator, and that would give me square root of 3 over 3. So it's not immediate for tangent, but we can capture the tangent values just by working with the coordinates that are given here on the unit circle. But for sure, we can directly get our cosine values. Those are the yellow x values. We can also directly grab our sine values. Those are the green y values. Thank you for joining for this investigation of creating the unit circle. See you soon.